This video contains tutorial for LS9, the curtain motor control circuit unit. It is of vital importance that you watch the video and understand exactly what we're doing, and then you can continue watching. The most important thing by your hand is if you go back to the lecture bit of LS9, all of the Boolean expressions necessary to implement the circuit. The first thing you will need to do is to define all of your input and output ports. For this curtain motor control chip example, we have 4 different inputs, namely the 2 sensors and the 2 buttons. And you will need to use the binary switch for them. For the outputs, we have 3 different outputs, namely the 2 motors as well as a light. It is also very important that you try to label all of these components the moment you drag them out. What you must do is, for example, on the input side for binary switches, it is recommended that you drag out individual wires just by a little bit, select the wire and right-click name. For this one, I'm going to name it sensor 2. To make it simple, I'm going to make the coupling button next to it. So let's call it button 1. And then below it, we can have button 2. And then sensor 1. The reason why I've chosen this order is that I noticed button 1 and sensor 2 is happening adjacent to one another to form output 1, and button 2 and sensor 1 is coupled together to form the expression for output 2. And then furthermore, button 1 and button 2 happens within a product term, which means they need to be combined together. However, it is totally acceptable if you choose to rearrange the order of these later on. So potentially you could also just have sensor 1, it's in its entirety, moved all the way up. This would totally be fine as well. But for now, let's just say we're using sensor 2, button 1, button 2, and then back to sensor 1. The next thing you're going to need to do is to label your output ports. Now sometimes you might just want to start with the inputs and then label your output then. So in this particular case, I'm actually going to just label the outputs first. This is going to be output 1. And again, if you want to name a specific component, the best way to do is actually to label the wires instead of the components themselves. And then finally we have the light. Now these are the same as in the course website, the lecture slides, so it should be very easy to see. Now the next thing we're going to do is we're going to implement individual terms inside our output expressions. Let's take a look at output 1 and output 2. You'll realize that output 1 and output 2 both share button 1 and button 2 inverted. So let's do that now. To be able to do that, we can use a single NAND gate. Now it's very important that you pay attention over here. There's a couple of different NAND gates. There's NAND 16, NAND 2, NAND 2 invert, NAND 2 invert. You can see the differences by looking at the diagram over here. And this is the one we want. If you select NAND 2 and then 1 invert, one of the input port has a tiny little circle, which means that this particular wire is inverted before feeding into the NAND gate. So we're going to need to select the correct one, drag it out, and establish some connections. It is very important that you check the connections by single-clicking the individual wires to see if the entire wire is highlighted in yellow. And in this case, the answer is clearly yes. So we have successfully established connection. The next thing you will need to do is to combine the rest of the terms together. Sensor 2 and sensor 1 are both inverted, so we can choose to use a NOT gate. For each and every one of them. Again, very important that you check the connection over here. It seems to be in place. And finally, we need to combine all of these with some AND gate. So in this particular case, we're actually combining 3 different terms using the AND operator. For output 1, this is button 1, inverted sensor 2, and inverted button 1 and button 2. So we can simply use a 3-input AND gate and then make the necessary connections. The 3-input AND gate operates exactly like a 2-input AND gate. Actually, two 2-input AND gates stacked together. And similarly, we can use the separate AND gate, a separate AND gate for output 2. Let's make the connections as well. And again, it is very important that you check your connections to see if they're actually connected. So let's do that. Everything looks good, and the output is actually showing up. Finally, at the end of the day, let's move this a little bit further. What we also need to do is to design the connection for Z. For this, we're going to use a single AND gate. Let's drag it a little bit further and then connect it to output 1 and output 2. Now we can start testing our connections. We can start testing the circuit, doing verifications. Button 1 should trigger output 1 to be positive. Button 1 and sensor 2 should disable output 1. Button 2 should trigger output 2. As you can see, we've made a slight mistake over here, since this is not supposed to be AND, this is supposed to be OR. Let's get an OR gate instead. Now the light is functioning correctly again. You can see button 2 indeed triggers output 2 and light, and sensor 1 disables that output. And when 2 buttons are pressed at the same time, all motor functionalities are disabled. Again, it is very important that prior to submission, you test your the implemented circuit on your own, doing verification. If you don't do this and I get your submission and I found out your circuit is actually not working, well, you're going to lose some points. And last but not least, please remember to save your circuit somewhere you can remember. Circuit files have the suffix .cct, as you can see over here. So that concludes the that concludes this tutorial. Thank you.